Algebraic expressions part 2. Here we're going to look at on example 1 to identify the terms. So we need to know what term means. The term is when your expression is separate by addition subtractions. You can say that's different terms. So when you're looking at this first problem, you have a plus 2ab minus a over b. Remember, multiplication was factor. Here, when you see additions or subtraction, we can say that's going to be different terms. So how many different terms we have on that problem? We have 1 term, 2, and 3. So we have 3 terms on that problem. What about next one? If we're looking at the next problem, we have 3 times x plus y, 3 times x plus y. I have addition right here, but the main sign is multiplications because you have 3 times something, right? So that is going to be whole 1 terms. So this is going to be 1 terms because you have multiplications between, right? And that separate by this subtractions, right? So this one is addition and this is subtractions. That's how you have 3 terms. Here you have 1 subtractions, 1 additions. So you're going to have another 3 terms on that problems. The first term have a factor, right? First term will have a factor, 3 times x plus y. On the second factor, you have 2 terms. But from the whole picture, you have 3 terms. What about the next one? The next one, if we're looking at this problem, from the whole pictures, you have 1 addition right there, and this is subtractions. So the whole picture, it's separate out into 3 terms. So this one have another 3 terms. And I'm going to show you, this is going to be 1 term, 2, and 3. 3 terms. In the first term, you have a factor, 2 factor, and second factor have 2 terms also, right? But from the whole thing, you have 3 terms. Next problem is asking you to express as the fractions. We know that division is same as fractions. So if we have 2 divided by 5a, we can rewrite this as 2 over 5a. Then the second one, 3x squared minus 2x plus 5 divided by x plus 2, we can rewrite this as the fraction form of the first term. First part of the division will be on the numerator. And x plus 2 on denominator. Next problem is asking to identify the like terms. So when we have our algebraic expressions, you can only add and subtract the like terms. So we do need to know what like term means. Example A, we have 9a plus 2b plus 5b. So when it's the like terms, it means you have to have same variable. So 9a, I don't see anything else with a, but I have 2b and 5b. This is going to be like terms. So later, when you realize if it's like terms, you can combine them. And that's what we're going to do next section, adding, subtracting, right? So that will be 2b plus 5b. So you're adding 2 plus 5, so it will be 7b. The next one, let's see if we have a like terms. Here, you don't really need to add or subtract. That's not what they're asking. They just want you to know you have a like terms. So I have 1a and 2a as the like term. And ab and minus 3b, you do not have like term because they don't have the same variable. Again, we're not adding or subtracting. We're just going to locate the like terms here in this exercise. So C, in this problem, you have 6r minus br. So this look like they're the like terms, right? Because you have r. And plus r squared, that's not going to be like term because the other two is just r. This one is r squared. So if you have a different exponents, that's not going to be the like terms. And minus 5br, that's not the like term because you're looking at as a br, right? This is going to be br, not r. So that's not going to be like term. And this is not like term because the square, right? The next one, let's see if we have a like terms. If we're looking at 5 times a minus b, I see I have another one with a minus b, and leading coefficient of that term will be 1. So we call that going to be like term. So this and that is going to be like terms. And you have a and b, that's not a like terms, and a is not even like term with a minus b. B is not the like term with a minus b. So these two are just the like terms. Exam 4, we wanted to know if we can tell given expression's degree. So example 4 is asking for identify the degree of the polynomial. Let's look at the first one, a, negative 3x squared. This degree is going to be the second degree. And how do we know that? Because this square right here, we know that's going to be second degree polynomial functions. Or we don't know function because we don't have equal sign, but it will be second degree polynomial. The next one, we have 2x squared times y cubed. This one, because this is all multiplications, right? We're going to add the exponents. So this exponents plus that exponent. So together it makes it 5, right? So we call this is fifth degree. The next one, we have 3 times x times y times z squared. So remember, if you have more than one variable, you're going to add all those power. If you don't have any power, it means you have 1 there, right? You have 1 there. Plus 2. So it will be 1 plus 1 plus 1 plus 2. So that's going to be 4. So this expression has 4th degree. The next one, you not only have a factor, but you have a term also. So you have 3 different terms. So if you have a different terms, your degree comes from one of the highest ones. So if you're looking at the first terms, you have x cubed. This first term degree is 3rd degree, 3, right? The second term degree is 2, 2nd degree. And this one don't even have a variable. we call that constant, right? So what's the highest? Well, the one with the higher exponents. So if we have different terms, one with the higher exponents will be the one that represent the degree of the whole expressions. So we're going to say this is going to be third degree. What about the next one? Next one, we have 3 terms. Out of 3 terms, look like the first term have the highest degree. This is going to be x squared, y squared, so 2 plus 2 is 4th degree. The last example, we're going to look at it in this section, evaluating the simple formulas. So we have P equals to N times T minus C for N equals to A, T equals to 250, and C equals to 140. What does that mean when it says evaluate this? It means you're going to replace all those numbers or a variable with the given numbers and see what you get. So it say N is represented with 8, so you're going to replace that. T equals to 250, replace that. C equals to 140, replace. So then your P is going to be equals to 8 times, remember order of operations from the other chapter, right? So you're going to do inside of the parenthesis first, which is 250 minus 140, you get 110. And now you have a multiplication, so when you multiply 8 times 110, you got 880 for P. So we call this as evaluating. So evaluate means you replace the value variable with given values. Then let's look at the next one. We have C equals to 5 over 9 times F minus 32 for F equals to 68. This formula right here is formula for changing when the Fahrenheit is given to Celsius. But even we don't know what the formula is for, when it's evaluate, you just need to replace the given variable with the value. So given variable with value is F equals to 68. So let's replace that and see if we can simplify it and find C. So we do the inside grouping first. So you're going to do 68 minus 32 so that you get 36. And then you do the multiplications. If you have a calculator, you can figure out 5 over 9 times 36. But let's say if I don't have a calculator. And this one looks simple, so let's see what I can do. 36, we know that's same as 36 over 1. And look like 9 goes into 36 4 times. So now I have denominator 1 times 1. Numerator is 5 times 4, which is 20. So 20 over 1 is what I have, which will be 20 for my C. Again, when it says evaluate, you just replace the given variable with the given number.